Consumption function exercises. This is part of the Business Capstone in Math 102, and this is kind of the more trickier part here. So I'm going to walk you through this part of Keynesian economics and the consumption function. So let's start with a definition. The science of economics deals with the use of services and the production, distribution, and consumption of commodities. The theories of Keynesian economics were first presented by the British economist John Maynard Keynes. He is credited with introducing the consumption function. The linear consumption function is an application of the linear functions we have already studied in this class, and it's very similar to the slope-intercept form. The consumption function is a mathematical model that is used to predict consumer spending behavior. So here is our traditional slope-intercept form of an equation right there. We have y equals mx plus b, where m is the slope of our line and b is the y-intercept of our line. Now the consumption function is a variation or an application of this slope-intercept form, except here we kind of change the variables a little bit according to their application. So we have capital C here kind of taking the place of y, and that is current consumption, or how much somebody is consuming. Then we have B, which is the marginal propensity to consume, which is our slope. So that's the same thing as our slope M in our slope-intercept form. And then Y sub D, that's how that's read, Y sub D right here. All that is the disposable income that a person has. And then A at the end, which is kind of like our Y-intercept, that is the autonomous consumption. So a lot of different words and terminology here in terms of our equation, but basically our function here is the same function we've been using now, just an application. And in this video I'm going to go over all of these different things and explain what all these things mean and how they're used inside the consumption function. Okay, let's take a look at an example now at the consumption function. We're going to go ahead and graph this. So we're going to graph the consumption function, which is right here, which is the consumption equals the marginal propensity to spend, which is B, and then Y sub D is our disposable income, and A is our autonomous income. Now we may not know what these things are yet, but let's just go ahead and graph just to kind of get familiar with what this equation looks like when we graph it. So we are going to plug this information in. Notice here, B, our marginal propensity to consume, is 0.6, and our autonomous consumption is 200. So let's first write that equation. So it's going to look like this then. C equals 0.6 Y sub D plus 200. Okay? Now remember, this is just like our slope-intercept form. You know, we'll think about this as y equals mx plus b. So 200, this is going to be our y-intercept there. So we can come over to our graph, and here's the y-axis right here going up and down. And so this thing is going to have a point right at 200. That's our y-intercept. Now I want to use this slope of 0.6. Now 0.6 of a slope is kind of difficult to graph. So I'm going to go ahead and find some points here. Maybe find another point so I can complete this graph. So let's see, I'm going to erase this slope-intercept form. Let's find a couple points on there. Like let's say, for example, I put 150 in for our disposable income. And you notice disposable income is like our x variable here. It's down here on the bottom. And it also is my cluttered variable. So I'm going to go ahead and put 150, a disposable income of $150 into this equation. And that should give us a point. So C is going to equal 0.6 times 150 plus 200. So 0.6 times 150 gives us 90. So this is going to be 90 plus 200, which is going to give us 290. So I have this ordered pair then. I plugged 150 in for X, or sorry, the disposable income, and out came for the consumption 290. So here's the point. Over 150, up 290, and I'm just going to have to kind of ballpark 290. So right about there. So we've got our 2 points there. We could get out our straight edge and graph that line. Okay, so connect those 2 points and graph that line. Let's go ahead and practice that idea of graphing this consumption function. So go ahead and pause your video player now and graph the consumption function when our marginal propensity to consume is 0.50 and our autonomous spending is 150. When you're done, hit play to see how you did. Okay, here we are ready to graph this thing. So let's take our consumption function and we're going to plug 0.5 in for our marginal propensity to consume times y sub d, and then plus our autonomous spending is 150. So again, this is our y-intercept here, a y-intercept of 150, so that would be 1 point for us. Now let's find another, and this shouldn't be too hard with a value of 0.5. So let's see, 0.5, let's just pick a value there. Let's say 300, so I'm going to take 300. You could have picked any value you wanted to plug in here. I just try to get myself a little bit of distance from the point that I have. It'll make my graph a little more accurate. Well, 0.5 is the same as a half, so if I take half of 300, that would be 150 plus 150. So my consumption then is going to be $300. So I have the point, the ordered pair. I plugged in 300 and I got out 300. So let's see, the point 300 is going to be 300, 300 right there. So I go ahead now and take my straight edge, connect those points, and I've graphed the consumption function where our marginal propensity to consume is 0.5 and our autonomous spending is 150. Using the information from practice problem 2, let's take a closer look now at the meaning of these variables and how the consumption function can be used to model human spending habits. So the practice problem you did right there, remember we had a y-intercept of 150 and then we had the point 300, 300, and we graphed that line. So all this line is right here is another graph of that same exact line. Now let's talk about these different variables. Okay, and the first variable I'm going to talk about is C, which is current consumption, the kind of consumption that's happening right now. So the variable C, current consumption, is the expenditures of an individual or household. Current consumption is determined by 3 factors. The percent of the disposable income spent, and that is our marginal propensity to spend. So basically what happens in any person or any household or something like that, they tend to spend a certain percent of their income. So that's the marginal propensity to spend. The disposable income, y sub d, which we've seen a couple times now, all that is the amount of money earned after taxes. So after you've paid your taxes, whatever you have left, that's disposable income. And the last one here is the amount of money that needs to be spent to live, and that's autonomous consumption. So even if you're not getting an income at all, people still need money to survive. So they need to have some shelter, they need to have some food and things like that. That sort of spending is called autonomous consumption. It's autonomous because it doesn't depend on how much money we earn. These are things we have to spend money on in order to survive. So again, we're looking at that same graph. Y-intercept of 150, our point was 300, 300. Same graph now, except now we're going to focus on the marginal propensity to consume, which is the slope of our line. This determines the slope of our line, how steep of a line we're going to get here. And so variable B equals the marginal propensity to consume. And a lot of times you'll see that abbreviated MPC. So consumers spend most of what income they have, but not all of that income. The percent of income that they spend depends on the person, but once that percent is determined, a person's spending habits are pretty consistent and pretty predictable. The marginal propensity to consume, represented by the variable B in the consumption function, is the percent of the disposable income that someone tends to spend. Okay, again, same graph, except here we're going to focus on now y sub d, or disposable income. So the variable y sub d is the disposable income, and disposable income is the total personal income left over after taxes have been taken out. The other variable we're going to look at here is autonomous consumption. So the variable A, autonomous consumption, So consumption is not entirely determined by wealth or how much money somebody has. People who have lost their job and have no income still continue to need goods and services, so they consume despite a current income of zero. Several factors influence autonomous consumption: future financial expectations, availability of credit, taxes they have to pay, personal wealth, etc. But autonomous consumption is a constant value, and it is the intercept, very similar to our y-intercept, of consumption spending. To help you understand how the consumption function is used to predict spending, let's use it to model the spending habits of Hannah. Now, Hannah is a freshman in college, and the graph you made in practice problem 2 tells the story of her spending habits. So when Hannah started school, she didn't have a job, and therefore she didn't have any income. But she still needed to eat, have a place to sleep, and spend some money on basic survival items. This spending is autonomous spending, and we can see on the far left side of the graph that Hannah spent $150 a week even when she had an income of zero. So if we look at this point right here, the first point we graphed, you notice here, down here is our disposable income at the bottom. She has zero disposable income, but she's still spending $150 a week. That's autonomous consumption because she needs to eat, sleep, and live and all those sorts of things. Now, let's continue on with her story here a little bit. So after being at school for 2 weeks, Hannah got a job at the library and started earning $200 a week. And while $200 a week helped her finances, she was still spending $250 to live. So earning $200 and spending $250 represents a point on the graph. This point, 200, 250, can be used with her autonomous spending point, 0, 150, to find the slope of this line. And remember, the slope of the line is her marginal propensity to spend, the likelihood of her spending her income. So let's see, here was the point that she had. She got this job at the library, and so she started making $200 a week. Okay, so even though she's making $200 a week now, if we look at her spending, we look at the point on Hannah's graph here, she's spending $250 a week. So she's spending more than she's earning still at this point. But we can use these 2 points then, this point here and this one that we started at, and we can use those 2 points to determine the slope of the line. And once we get the slope of the line, that is her marginal propensity to consume. So let's go ahead now and take a look at the slope of that line and see how we can use it to get a consumption function that will predict Hannah's spendings. Okay, so here we had the points 0, 150 and 200, 250. Remember, to find the slope of a line, it's the change in y over the change in x. So if we look at our points here, the change in y, if we go from 150 to 250, that's a change of 100. So that gives us our change in y. And then our change in x, that was from 0 to 200, so that's a change of 200. So basically, we get this slope of 1/2, and we'll write that here as a decimal. Usually the marginal propensity to spend is 1/2. So what this tells us then is that when Hannah starts to earn money, she is going to spend half of the money that she earns. So from the data that we got about Hannah here and her spending habits, we now have a prediction about how she's going to spend her money. She's going to spend approximately half of that. So once we know Hannah's autonomous spending and her marginal propensity to spend, we can predict how much money she will spend as she starts to earn more money. And so here is Hannah's consumption function right here. So we have our marginal propensity to spend, which is 0.5. Remember, we're saying Hannah's going to spend about half of her disposable income. We also have her autonomous spending, which is $150. And now we're all set. We can predict how much money Hannah's going to spend as she starts to make more money. Okay, let's go ahead and pause your video player now and answer practice 18. When you're done, hit play to see how you did. Practice 18. Use the graph and the consumption function that we found for Hannah right here to answer the question about Hannah's spending. So let's see. Use the graph to estimate the amount Hannah will spend, C, which is her consumption, at each given amount of her disposable income. So let's see. When Hannah has a disposable income of $400, which would be right down here is $400, how much money is she going to spend? Well, all we got to do is travel up, and we'll see that right there, she's going to spend, so our consumption at this point, if she spends, or she earns $400, she's going to spend $350. All right. Let's see. Her disposable income is $100, which is right here. Hannah is going to spend $200. And if her disposable income is $350, looks like Hannah's going to spend, that looks like about $325. So somewhere in there, as long as you're close to $325 or somewhere thereabouts, Hannah's going to consume $325. All right, let's go to the next part of this question. Use the function to calculate the amount Hannah will spend, C, at each of the given amounts of disposable income. So now, we are no longer going to estimate these things. We are going to figure this out for sure. Remember, right up here in part C, we kind of gave an estimate of $325. Let's see if that's right. So what we're going to do now is we're going to use the function. So here is our function for Hannah's spending, 0.5 y sub d plus 150. Now we're going to plug this information in. So let's see. We have 0.5 times 350 plus 150. Now we're going to get an actual accurate calculation here. All right. Let's see. Half of 350, that's 150 plus 25, or 175, plus 150. That's going to give us 325. And so that's kind of what I ballparked or guesstimated up there from the graph. So that first one is going to be 325, just like we estimated from the graph. Now the second one, her disposable income of $700. So Hannah's starting to make more money. Notice that goes off the graph, but we can still use the function here. So we're going to have this 0.5 now times $700 plus 150. Okay, half of 700 is going to be 350. And 350 plus 150 is going to give us 4, is going to give us $500. All right, let's take a look at now at example 19. Greg has a weekly autonomous consumption of $200 and a week where he spent $350 after earning $250. Graph the consumption function for Greg and use the points to identify Greg's marginal propensity to spend. We're also going to need his autonomous consumption, and then we're going to be able to write a consumption function for Greg. All right, let's first graph this thing. So, has a weekly autonomous consumption of $200. That means he's going to spend $200 even when he has no income at all. So, zero income, $200. That's our autonomous consumption point. So we'll write that up here. That's the point 0, 200. The next point that we have, we know this, that he spent $350 after earning $250. So that's it's written in the word reverse order here. Notice he earned $250. That's what's coming first. That's his disposable income, or X value, and then he spends $350. So the point is going to be $250, $350. There's our point. So now we're ready to graph our line for Greg. So this line kind of models Greg's spending habits. If we get the slope, we've already got our y-intercept here. All we need now is the slope, and so the slope of this thing is going to be our change in y over change in x. Let's take a look at change in y. So from 200 to 350, that is a change of 150. And our change in x, 0 to 250, well, that's a change of 250. So all we got to do is simplify this and get this down to a decimal, and will give us our slope there. So Greg's marginal propensity to consume is 0.6. Now we're ready to write a consumption function for Greg. So let's see. It's going to be 0.6 times disposable income plus the autonomous spending, which we already decided right over here when he had zero income. He spent $200. So there is our consumption function for Greg. Go ahead and pause your video player now and answer this practice question 20. When you're done, hit play to see how you did. Question 20. Yadira has a weekly autonomous consumption of $300 and a week where she spent $340 after earning $260. Graph the consumption function for Yadira. Use the points to identify Yadira's marginal propensity to spend, and then finally write the consumption function for Yadira. All right, let's see. Her autonomous consumption was $300, so that's the point 300. Zero money, she's still spending $300. Now, she also spent $340 after earning $260, so that point would look like this. Earning $260, spending $340. So I come over here $260 and come up $340. So I'm just going to kind of estimate these things on the graph. We're not going to be totally accurate with this, but maybe right about there is spending $260 and spending $340 after earning $260. So I'm going to go ahead and graph then a consumption function line for Yadira. And now we want to use these points. Remember, our first point was this, 0, 300. We want to use these points to determine the slope, because the slope is going to be Yadira's marginal propensity to spend. So remember, slope is change in y over change in x. So let's see, our change in y, we're starting at 300, going to 340. That is a change of 40. Change in x, starting at 0, going to 260. Okay, so we'll divide that out. Okay, we're going to get a decimal answer here. Let's take this out to 3 places. If you didn't take it out to 3 places, that's fine. I'm going to take this out to 3 places just for accuracy's sake. You know, we're dealing with this number now. We want to be pretty accurate. So take this thing out at least to 2 decimal places for sure. Okay, once we have now her marginal propensity to spend, then we're ready to write the consumption function for her. So her consumption is going to be her marginal propensity to spend times her disposable income, and then plus her autonomous spending, which was $300 a week. Let's go ahead and practice now question 21. When you're done, hit play to see how you did. 21. Graph the consumption function for Darian, who has a weekly autonomous consumption of $100 and a week where he spent $320 after earning $230. Identify Darian's marginal propensity to spend, and then let's write a consumption function for him. Okay, so he has a pretty low autonomous spending here. It's just $100. So there's 1 point for him. The other one, he earns $230 and spends $320. So $230, spending $320. Looks like right about there. Again, we're just estimating here, but so you should end up with something like that. So since Darian has a pretty steep line here, that indicates he's spending a lot of the money that he earns, basically. If we have a flatter line, then somebody's marginal propensity to spend, they're spending less of the money that they earn. But Darian's got a pretty steep line here, so he's spending a lot of the money that he earns. Okay? Now, let's go ahead and find the marginal propensity to spend, which is our slope. But remember, we use b for that, so b is our change in y over change in x. I used the m last couple times, just so you'd be familiar with that. But I think we're ready to move on now and see that the b is our marginal propensity to spend. Same thing as the slope. Let's get our points written down here. So we had 0, 100. And the other point was he spends $320 after earning $230. Okay, so let's look at our change in y and change in x. Let's see. Change in y starts with 100 and goes to 320. That is a change of $220. 0 to 230, that is a change of 230. Again, let's take this out to 3 decimal places. 957, 957. So that is his marginal propensity to consume. So let's see, his consumption function would be 0.957 times his disposable income, and then plus $100 of autonomous spending. Okay, so it's no secret that spending habits have a direct impact on a person's ability to save. We can use the consumption function along with the function now consumption equals disposable income to predict when a person will save money, build wealth, or when they will dissave, which is create debt. And so here we have the graph of C equals YD right here. And you notice it just travels up at a 45-degree angle, meaning this thing has a slope of 1. And this line represents basically spending every cent that you make. So this line right here, if we notice, if we earn $50 of disposable income, we're spending $50. If we earn $100, we're spending $100. $150. So somebody that was operating on this line right here, the line C equals YD, would spend every cent that they made. And they would never save, but they would also never go into debt. They would always be, at the end of each week, they would be breaking even. So what we'll do is we'll take this line, kind of this break-even line, and we can compare it to somebody's consumption function, and we can find out how much money they have to earn for them to either break even, make money, or stay in debt. Okay, so now let's go ahead and take this line now. What we're going to do is take this line and kind of examine some of the people we've looked at in their spending habits. So I'm going to graph C equals YD over Hannah's consumption function. And remember, that was Hannah's consumption function before. And we'll be able to answer some questions here. So remember, this thing is, you're spending exactly as much as you have. So at 0, you're spending 0, 50, 50, 100, so on and so forth. So I can graph this line going right up this 45-degree angle there. So there's the graph of the line C equals your disposable income. C equals your disposable income, spending exactly as much as you earn. Let's take a look at question A now. If Hannah has a disposable income of $200, by what amount is she saving or dissaving? So here's a disposable income of $200. Let's take a look. If Hannah was spending right here exactly $200, she'd be breaking even. But notice with Hannah's consumption function, she's spending $250. So that means she's going into debt this week $50 because she's gone above the top of this graph here. So she's losing money. So she is dissaving, and that's a weird word, but that is actually a word in the business world. She is dissaving at this point $50 a week, if that's how much she earns. All right, question B here. How much disposable income does she need to make in order to break even? Well, let's look. You can see right here where the two lines cross, where the graph of our two lines cross. And so notice with Hannah's consumption function, right there, if she earns $300 a week, then she's going to be at the break-even point. So she needs to make $300 a week to break even. Okay. Question C. How much will Hannah save per week if her disposable income reaches $400? So now when Hannah reaches $400, you can see that now her consumption function has dropped below. It's dropped below this line where you're spending everything you earn. So she's right here. She's only spending $350 when she's earning $400. So you can see she's 50 down below this line right there. So she's going to start earning $50 a week. So she will save $50 per week. Go ahead and pause your video player now and answer practice question 23. When you're done, hit play to see how you did. Okay, so we're going to graph this spend as much as you earn equation over Greg's consumption function so we can answer some things about when Greg is dissaving, breaking even, and when he starts to make some money. So you should have graphed this thing at a 45-degree angle. Spending is matched exactly as much as you save. Okay, and you can see that Greg is a little bit more of a spender than Hannah was. So let's see, if Greg has a disposable income of $250, by what amount is he saving or dissaving? So $250, it's not looking good for Greg. Break even would be $250, right? He's spending $350. So he's spending $100 more than he actually makes. So he is dissaving $100 each week. Okay. How much, question E here, how much disposable income does he need to make in order to break even? Well, let's look at our lines here. The break-even point is right there. So Greg needs to earn $500 a week before he's making as much as he spends. So he needs to earn $500 a week to break even. F. Use the equation to determine how much he will save per week if his disposable income reaches $750. All right, well, let's use his consumption function here. And we'll plug that $750 in for his disposable income, so it would look like this. 0.6, 750 plus 200. Okay, so we get 450 when we multiply 0.6 times 750 plus 200. So his consumption there is going to be $650. Okay, so his consumption is $650, but he's earning $750. So he's going to save he will save looks like $100 a week if he earns this $750. All right, pause your video player again and answer practice question 24. When you're done, hit play to see how you did. Question 24. All right, we're going to graph the break even. C equals disposable income. Okay, over Darian here, and you can see that even everywhere on this graph now, Darian is spending more than he makes. So let's see. If Darian has a disposable income of $100, by what amount is he saving or dissaving? All right, here he has $100 of income, and he's spending $200. So he is going to be dissave $100 each week. All right, B. Use the equation to determine how much disposable income he needs to make in order to break even. So one way we could do this is we could keep plugging disposable incomes in here, guess and check, and figure out when it matches. That's one way to do it. The easier way to do that is use some algebra here. You notice if he's going to break even, he will make as much as he spends. Well, this is how much he spends. C is how much he spends. How much he makes is Y sub D. So when those two are equal, consumption over here equals the amount of money he's earning, they'll be the same. Now, notice if those are the same, we can use what's called substitution here. So here's our consumption function for Darian. Okay, basically, these are the same. So I could replace, in this case, I can replace Y sub D with C in this equation. So I'm going to come over here and I'm going to put C in the equation for it. Since those two are equal, he's spending as much as he's earning, I can replace that with C, and then I get this equation, 0.96 C plus 100. Well, now I just have one variable in the equation. So I can solve this. Basically, I would get the variables to one side, so I'd minus this 0.96 C from both sides. Okay, the right side's pretty easy because this is going to drop out for us and leave us with 100. The left side, if I start, this is 1C. To have a C there is the same thing as having 1C. So if I start with one of those things and I take away 0.96, I'm going to be left with this, 0.04C. That's what will be left over. And then to solve for C, I'm just going to divide by 0.04. And And when I do that, the dairy is going to have to make $2,500 a week to break even.